All right, today we're moving on to lesson 1.7 on three-dimensional figures. So first we're going to talk about a polyhedron. So a polyhedron is a solid with all flat surfaces that enclose a single region of space. So for a two-dimensional figure, we call those polygons. So a three-dimensional figure is called a polyhedron. It's similar to a polygon. It's got the same characteristics. You've got to have flat surfaces, that kind of thing. So all of your flat surfaces are called faces. All of the line segments where the faces intersect are called edges. So like for example, this is a flat surface. That's a face. This is an edge. That's where it meets another face. And then the points where all the edges intersect are called vertices. Okay, so there's several different types of polyhedron we're going to talk about today. First, we're going to talk about prisms. Okay, so prisms have something called bases. They have two bases, and the bases are parallel and congruent. And so it's important to note, though, that prisms are named by the shape of their bases. So when you look at a prism, first you have to decide, well, what shape is the base? And so that could be the tricky part for some people. So let's look at this one. So obviously it's a triangular prism. I've got that typed here. But to decide that, I'm looking for two shapes, two bases, and then I want them to be parallel and congruent. So that's why I picked the triangles. There's my two triangles. They're parallel. They're across from each other. They're not ever going to intersect. And they're congruent. They're the same size and shape. Okay, so that's why this is a triangular prism. Look at the next one. This is a rectangular prism. Rectangular prisms are a little bit different because you have a couple of options for your bases. So just to mix things up, I'm going to pick this base. I have two of these. They're parallel and congruent. They're rectangles. So this is a rectangular prism. You could have picked the front and the back again, like I did with my triangular prism, and it's still a rectangular prism. Those are still rectangles, and you would get the same thing. The last one, this one is called a pentagonal prism. Again, I picked my bases. That's where the name comes from. My base is a pentagon. There's two of them. They're parallel and congruent. It's a pentagonal prism. Okay, a special kind of prism that you need to know about is a regular prism. So a regular prism is going to have bases that are regular polygons. So we talked about regular polygons in our last video. They have those three things. They have to be convex, they have to have all congruent sides, and all congruent angles. Okay. All right, moving on. We also have pyramids. The difference between a pyramid and a prism is that a pyramid only has one base. A pyramid, though, like a prism, is still named by its base. And so you're going to find the pointy part of your pyramid. It's the vertex. And the base is across from it. So this is a triangular pyramid. This is a rectangular pyramid. And this is a hexagonal pyramid. Okay. All right, so let's do a few examples. This one says first to identify the solid, and then we're going to name these things that it's asked for. Bases, faces, edges, and vertices. So first of all, when I look at this, it's definitely a prism. I know it's a prism because it has two bases. They're parallel and congruent. So it is a triangular prism. So I'm going to start by naming my bases. I just outlined them for you in purple. They're triangles. So I'm going to do triangle. And then I'm going to pick a vertex to start at. I'm going to start at I. So I, G, H. The other one I can call triangle, L, K, J. I went in a different order that time just for fun. Okay. Your faces are going to be all of the other flat surfaces that are not your bases, but your other flat surfaces. You have three other flat surfaces. They're rectangles. You can name a rectangle just using 4 points, the 4 letters that surround that rectangle. So I'm going to do the one on the bottom first, this bottom rectangle. I'm going to start at G. So remember, you have to go in consecutive order. You got to go around. So I'm going to do G-I-L-J. G-I-L-J. That makes up that bottom rectangle. All right, I'm going to do the one that's on this right-hand side. I'm going to start at I. So we've got I-L-K-H. I-L-K-H. And then the last one, I'm going to do this one over here that's on the left-hand side, kind of in the back. We'll start at K this time. How about K-J-G-H? K-J-G-H. In case you're wondering, my allergies are still messed up, and I'm still struggling to write. Okay, so the edges, remember we said the edges are all of the line segments where the faces meet up. So this one has quite a few edges. I'm looking for all of the line segments. So we'll go through and name them. So there's KL, another line segment, KJ, another one down here, JL. We've got HI, HG, GI, then we've got IL, GJ, and HK. And the last one is going to be the vertices. Remember, the vertices are just the points. So I can just list those points. Remember, you can write a point just as a capital letter. So you've got H, G, I, J, K, and L. All right. Let's look at the next one. I think I'm going to skip doing all of this one because it works the same. But I do want to name the solid with you real quick. So this one just has one base. So it is a pyramid. It's a rectangular base. So it is a rectangular, about to spell that way wrong, rectangular pyramid. Okay, so the base of the rectangular pyramid, of course, is that rectangle down there. Your faces are the 4 triangles. Your edges are all the line segments, and then your vertices are all those points. All right, last thing for this video. These are not polyhedrons, okay? Not polyhedrons. I want you to think about that for a second. Why? Why are they not polyhedrons? Okay, so if you'll remember to yesterday, I told you that if something is a polygon, it can't have curves. These all have curves. So they are not polyhedrons because they have curves. They're in their own special category, kind of like circles. They're not polygons. They're not polyhedrons. Okay, so we've got cylinders. Cylinders should remind you of prisms in that they have 2 bases that are parallel and congruent, but the bases will always be circles. Cones, that should remind you of pyramids in that there's just one base, but your base will always be a circle. And then a sphere is kind of out there on its own. It's its own little category of fun. So that sphere is just kind of like a ball. Okay. All right. You know what? This lesson has 2 flip books, and I was thinking I wouldn't have time to do them, but I think I do. Can y'all hang through one more? Almost done. So let's talk about some intersections of lines and planes. I think I want to. Yeah, I do. Let's do it. Okay, so 2 lines intersect at a point. Here's that point. If you have 2 lines, they're going to intersect at a point. So here's an example. Name the intersection of line LM, LM, so that's still this line, and PM, this line. Where do those 2 lines intersect? Right there at one point, point M. 2 planes. So now I've got 2 planes. Remember, it's hard to draw a plane, but that's the best I can do. They intersect right here. So when planes intersect, they form a line. So 2 planes intersect to form a line. So let's look at an example of that. Name the intersection of plane D. So here's plane D and plane A. So here's plane A. So what's on both of those planes essentially? So if you look at that, we're looking for a line. This line right here is where those two planes meet. It goes through plane D and it goes through plane A. Remember, you can name the line with any 2 points you like on that line. I'm going to name it line XR because that's what I see first. You could have named it line RZ or line ZX as well. All right, last one. A plane and a line intersect at point. A plane and my line kind of goes through it. They intersect at a point. This picture should kind of remind you of like if I took my pencil and I stuck it through a piece of paper. So I've got a line going through a piece of paper, my pencil going through a piece of paper, and they're intersecting just where the pencil is touching the paper. So that's a point. So here's your example. Name the intersection of plane HEF. Let's find that plane real quick. Excuse me. HEF. So here's HE and F. Remember, a plane just needs 3 points to be able to name it. But a plane is that flat surface. So here's points H, E, and F. But what flat surface are they making up? Well, they're making up this top of this prism. Okay, so here's plane HEF. It didn't include point G when I named it, but remember that's because in a plane you just need 3 points to name it. So we want to know where plane HEF intersects line GC. So here is line GC, and we want to know where do those two things touch. We know it's going to be a point, so obviously it is at point G. Okay, this right here, this question is usually what sends people for a loop. So when you're working on your assignment today, please don't hesitate to contact your teacher if you get stuck on the intersections. All right, see you later.